Hello, friends. This is Evan Transu here, aka Detective Ev. I was not available for this particular recording, so we are actually doing this one as a pre record that we're now streaming live. So we always want to be transparent with you guys. If it is live and it was pre recorded, we will always tell you. In this segment, we're going over the stress and hormones profile, which we've done on Lunch and Learns before. But instead of Lucy and I explaining it, we brought in the big guns. We brought in Dr. Aron Gonshor, and he will be breaking this lab down for you today. And there are a lot of nerdy details in this one. So we hope you enjoy. If you do have questions, you can still put them in the chat, and we will make sure to get back to those in due time. Thank you so much, and I'm looking forward to seeing you.
Okay, good morning, everyone. Well, I suppose it depends what time of day you're watching this, but it's currently morning while we're recording this. I'm Lucy McKellar. I'm going to be your host today. Evan is out today, so it's myself and Dr. Gonshor. If you're not familiar with Dr. Gonshor is the CEO and founder of Fluids IQ. He's also currently the scientific advisor for FDN. So we've had this relationship with him for quite a while, and obviously he is the founder of a lot of our foundational tests throughout FDN. As part of the Lunch and Learn, we are going to be going over the ones that Fluids IQ have created for us with Dr. Gonshor. So we're very excited to have him here today. We're going to be going over the sex hormone panel. And thank you very much for showing up and for doing this for us, Dr. Gonshor. We really appreciate it. We've had you on a couple of times now, and there's always requests for more. So yeah, thank you so much for coming back.
It's my pleasure, always.
Fantastic. So I suppose we should dive right in. Obviously the SHP is probably one of our, I mean, obviously we have our five foundational labs, but the SHP, I mean, it's part of the core of FDN, and it really dives deep into what we do here. So yeah, people are always interested to learn more about this test. So let's get into it.
Well, let's do that. And
Yeah.
You're absolutely right. It is the core of what we really do offer, and it's extremely important. So we're gonna discuss, as you said, the stress and hormone profile. In fact, what we're really going to be looking at is the advanced stress and hormone profile, and you'll see why that is important. And here is a typical page that you would see when you get the first page of a stress and hormone profile, the advanced. And why do we have the various tests that we do on this particular profile? And so the first thing that you see here is that there is a stress profile. What does that mean? It's adrenal function. The cortisols, in this case, 4 cortisols, and the DHEA S, as well as the ratio. Very important because it tells you about the effect of stress. The second is the female or male hormone profile. So here you see testosterone on the right, and estradiol and progesterone, the female hormones, and I'll explain some of that in just a moment. Then we have the metabolic profile, because here we're discussing the advanced stress and hormone profile. The regular stress and hormone profile does not include insulin, which is what we include for the advanced, but it is very important, and it gives you an idea of the metabolic status that an individual is in. So we are testing insulin, both fasting and non-fasting. We'll go over that in a minute. Then we have melatonin, which talks to you about circadian rhythm, the rhythm of life over a 24-hour a day, and the importance of that, as well as the antioxidant aspect of what's going on. That's why melatonin is so important. Again, we're going to go into each one of these in a few moments. And last but not least, a look at the mucosal immune profile of that individual, utilizing as a biomarker for that secretory IgA. So let's jump right in by first remembering, why are we doing this in saliva? Remember that each medium, saliva, blood, urine, each has its advantages and disadvantages. And in the case of saliva, what has made it so interesting as a medium for testing in the last, let's say, 20 years, 25 years, is the fact that by the nature of the salivary glands and so on, it ends up allowing only the free steroid, the steroid that is not bound up with other proteins as it is in blood. It allows us to look at the free steroid. And it is actually the free steroid which is able to be bioactive. That's what actually ends up being able to get into the tissues and do what these analytes are supposed to be doing. In the case of steroids, do what the steroids do, but they need to be bioactive. And only about 2 or 3% of steroids at any moment in time in the body are actually active. The rest, as you see on the left, are bound up. When they're in blood, they're bound up with anything from albumin, which is a non-specific protein binder, or the sex hormone binding globulins, the SHBG, it binds estrogens and androgens, or a protein that binds cortisol and progesterone. So, and we're not going to get into the reasons why they're bound up today. That's a separate lecture. But what you do need to understand is that when steroids are in blood, almost all of them are bound up. They can't interact with the tissues. And the body will utilize that bioactive fraction, both in the blood and in saliva as it happens. So let's take a look at the one aspect of this test, the stress profile. In other words, adrenal function, looking specifically at cortisol and at DHEA, or the sulfated form, which we test for, DHEA-S. That is what you see mostly in the body. And that you would see on the upper right of the test when you actually get it back in your house. And you see cortisol and DHEA-S. And what are we actually looking at? Well, remember that if you start looking at principal pathways of all of the steroids, starting with cholesterol and so on, you start to see a number of interactions. And one of the things you see is that pregnenolone, which has always been called the mother hormone, will, after a couple of steps, form DHEA, which then, if you move along the various pathways, is responsible for any number of things, including the formation of testosterone, as well as estradiol and E1 and E2, the female hormones as well. So immediately you begin to see that there's a relationship of the adrenal hormones as well as the male and female sex hormones. Here, for example, pregnenolone also forms progesterone, one of the female hormones, which eventually will form cortisol, or its storage form, cortisone. So I want you to keep all of that in mind. And I'm not going to go through all of the things that cortisol gets involved in, but you can see from this short list, because there are other things, cortisol is implicated in almost all of the major functions of the body. It's very important to recognize. So you need to know what is the stress status of that individual. How much cortisol are they actually producing? Because it's going to be very important in the functioning of that person's body, as will DHEA. We know that it's extremely important. We'll go over that in a moment. And it also decreases with age. So the amount of DHEA that an individual has is up to about 20% of what you have when you're young. By the age of 70, you're down to 20%. And the result of that is less capacity of the sex hormones to protect brain function, which is one of the things sex hormones do. The brain has a greater susceptibility, therefore, when you age, to the neurotoxic effects of cortisol. And I'm intertwining all of these different aspects, adrenal function, and you'll see this with sex hormone function, etc., which is one of the reasons we put them all in this one test. If you look at cortisol specifically, cortisol has what is called a diurnal or a daily rhythm, which is quite apparent. So if you have someone who's going through a normal rhythm, and this is what you would see on the second page of a typical report, you would actually see a schematic, a diagram, where we would tell you what that individual's cortisol levels are during the whole day. And one of the things that you need to remember is that cortisol is highest in the morning because it's being produced at night if everything is going well. And then after what's called a cortisol awakening response, which takes place in the first few minutes, you then get the highest level during the day normally, and then it goes down during the day, but that can change. If you have hypercortisol effects, or you're getting all kinds of exogenous cortisol for some reason, you can get elevated levels. Or if you have hypoadrenal function, as in Addison's disease, etc., you can have depressed functions. So you can have hypercortisol. In other words, it doesn't go down in this slowly decreasing level, but actually stays at a higher level. That's with hypercortisol. People with Cushing's syndrome, for example, will have that. Or there's some active stressor, which is just not giving up. Or in depression, you will have it go down, but then it'll go up in the evening, which causes sleep disturbances. Or what happens after constant stress, you eventually get what's called pattern 3, which is a hypocortisol curve. There's almost no cortisol being produced. Let's take a look at DHEA. And remember, I told you DHEA is implicated in all kinds of other steroids, mostly the male and female steroid hormones. So if DHEA is in trouble, you are going to see problems in sex hormones as well. And there is a conversion of that both in the brain as well as in the peripheral tissues, the gonads, adipose tissue. And so DHEA is important for a number of reasons, very important, that has a lot of biological significance. In the neurological system, acts as a neurosteroid. In the immune system, it is involved in proliferation and differentiation of a whole number of T cells and B cells and macrophages. So it's extremely important in the immune system, in bone metabolism, in the cardiovascular system. Most people don't realize how important it is in influencing blood pressure regulation, etc. And of course, in the reproductive system as well, which we're not going to go into today. We're just giving you a quick tour of all of that. So DHEA is important. And what becomes extremely important is when you take a look at adrenal function in general, looking at cortisol and DHEA. And remember that cortisol normally, as I said, is high in the morning, and then it goes down during the day. But what happens if you have constant stress, chronic stress, you go through stage 2, in which cortisol begins to decrease during the day, including the morning, as does DHEA. And then it eventually goes to stage 3, which used to be called cortisol or adrenal exhaustion. In other words, the body says, the adrenals say, we can't do this anymore. We can't produce cortisol anymore. And that is a very, very dangerous area to be in. And many people do get into that situation, and that must be dealt with immediately. Of course, what you'd rather do is get them into stage 1 or see them when they're in stage 1 or stage 2, which is a very important reason for doing this particular test. And I'm just showing you here that stress is going to affect cortisol, DHEA, the ratio between them, the effects that cortisol has in mobilizing glucose and fatty acids and amino acids. the effect of cortisol, which has catabolic effect, to DHEA, which has anabolic effect. And how does that ratio affect all of the different functions that one is looking at? And I'm showing you just some of the many functions that an adrenal stress index, that ratio, is going to affect. That's all we're talking about right now for cortisol and DHEA. What about the female hormones? Well, we very quickly give you the 3 levels. It is not meant to be the most exact way of looking at these hormones, but it is a quick moment in time look at the hormones themselves. And you will see this on the report, excuse me, testosterone, as well as the estrogen in the form of estradiol and progesterone. And so that's what you are going to be seeing on the report. And remember, I showed you this a little earlier. You're going to see progesterone, the estradiol, and testosterone. And these have tremendous amount of effects all over the body, of course, in terms of reproductive effects, no question. But it also has effects on other areas. And I'm showing you here just one particular group, the hormonal effects on the intestine and what that does for intestinal permeability, also known as leaky gut. Cortisol, for example, modulates inflammation and permeability in the gut and the neurotransmitters. Estrogen, estradiol, modulates paracellular permeability, intestinal permeability. It affects the tight junctions. Testosterone, if you have a lack of testosterone, it delays intestinal healing, not just in men, but in women. Remember, women have testosterone as well. Progesterone, treatment with progesterone protects the intestinal lining from all kinds of injury. And the thyroid, a lack of thyroid stimulation of gastric and intestinal cells leads to all kinds of ulcerations and intestinal permeability. So you need to be aware of that. What about metabolic profile? Remember, we're talking here about the advanced stress and hormone profile. Well, let's take a look at insulin. Insulin is key. And a lot of people say, insulin in saliva? Yep. Just remember that insulin, after you have a meal, blood glucose levels immediately go up. So insulin is released from the pancreas, and it stimulates the uptake and storage of glucose in muscles, in the liver, in fat cells, etc. So glucose is removed from the blood and is stored in tissues. You don't want it in the blood. Well, a few hours after a meal, if you look at the bottom, blood glucose has dropped because you're many hours after a meal. So what does the pancreas do? Glucagon is released from the pancreas, not glucose, glucagon, and it stimulates the liver to do what? To break down glycogen, which it has been storing. Glycogen is a form of storage of glucose, and it synthesizes new glucose because the body needs glucose for whatever is going on. So you have a regulation of glucose to attain normal ranges in blood. And insulin is a key aspect of all of that. And if you begin to have a problem with insulin resistance, meaning the cells become resistant to insulin, that's a big problem. And you have that a lot in people who are obese. It's a fat storage condition, and they enter into what's known as the metabolic syndrome. And the metabolic syndrome, everyone should be aware of, not just for anyone you're going to be treating, but for yourself. What is the syndrome? Elevated fasting glucose, elevated triglycerides, that means elevated lipids, elevated blood pressure, low HDL, cholesterol, and central, that means abdominal obesity. These people have increased salt retention, increased uric acid. They get chronic kidney disease, hypertension, fatty liver cirrhosis, and type 2 diabetes. All the wonderful things which we'd rather not have. And if you think it's not a big problem, it is a major problem. Metabolic syndrome is seen in greater than 30% of all US adults and greater than 50% in those over the age of 60. It's a massive problem. And 88% of the population in the US have at least one component of this metabolic syndrome. And so when you're looking at testing, you need to know that there are three things that have to be there, have to be easy. Sample procurement, that has to be simple, has to be inexpensive, minimal discomfort. It has to be able to show specific biomarkers that are associated with health or disease. And the technology has to be accurate. And saliva is able to fulfill all these three prerequisites. And so for all of these reasons, including many studies, which show how saliva and blood can both test for glucose and insulin, it is important that you recognize that saliva can be a medium for that. And when you are testing for this, you are given a little paper that comes in the kit, which also is called the carbohydrate challenge test. It's like an oral glucose tolerance test. You want to see what happens, not just when a person is fasting, but what is when they're not fasting? What happens when they take in a measured amount of carbohydrate? Is their body able to respond with the right amount of insulin, etc.? If not, then you may have, in fact, insulin resistance. So all of that is to say that in saliva and in this test, you can get a look at the metabolic status of the individual. It can tell you what is going on very quickly. As a screening test, do they have a metabolic problem? Is it the way to diagnose anything? Of course not. None of these tests are diagnostic, but they're important as screening tests. And if you think that that is not important, look again. Why are we doing these on the same test? Look at the cortisol effect on insulin. Remember that cortisol is a potent insulin antagonistic hormone. It inhibits insulin secretion. It, in fact, stimulates glucagon secretion, which, as I told you, is when the pancreas does just the opposite of insulin. It disrupts insulin signaling. So there's less insulin release. It, in fact, reduces GLP-1 production. That's the big thing today. It induces the expression of key gluconeogenic enzymes. It's doing just the opposite of what you want. And so knowing what the cortisol level is extremely important to know if insulin is functioning well. Here's another thing on the test, which is testing circadian rhythm and antioxidation. That's melatonin. And you'll see that we test for the daytime melatonin around noon. And to understand why this is important, you have to remember again, sleep cycles. Remember, normally you need about 7 or 8 hours of sleep in order to allow the body to go through its 4 cycles of sleep. That's what we all need. If we don't get that, it's going to get you at some point. And that means you go through 4 cycles. The first 2 are deeper. And as you continue, you go through the 4th and then sometimes even a 5th. And you go from stage 1 down to deep sleep, back up to REM, which is rapid eye movement sleep, about 25% of sleep time in adults, and in infants, it's about 50%. And non-REM sleep represents the other 75%, 4 or 5 cycles per night. And the first 2 cycles are longer. And remember, we all need that. And functions of the body are influenced by the sleep stage in the cycles, may be improved by a whole number of factors. And there are issues that are influenced by circadian rhythm, and they will respond better to those people who have a good circadian rhythm. Now, what does that mean? If you take a look in the evening, this is during the day, in the evening, the pineal gland in the brain begins to produce more melatonin, and it peaks, at around 3 or 4 o'clock in the morning, and then drops down by early morning, and then is very low during the day. Remember what happens if this particular part of the circadian rhythm, if this nighttime rhythm ends up happening during the day. What happens if it's in the morning or it's in the afternoon, as happens with people who have disturbed circadian rhythm? This will disturb the way in which all of your other bodily functions work, including any number of issues. And here I'm just giving you a whole series of issues of digestive function. The sleep stage will influence any number of aspects of motility and all of these different things you see on the left. The influence of circadian rhythm will have a massive effect on gastric acid secretion, on intestinal absorption, any number of these issues. So the circadian rhythm is extremely important. And melatonin, which is the key part of this, is a multifaceted hormone. It comes originally from tryptophan, which comes from our diet as well as bacteria. It'll be turned into serotonin. That's the happy neurotransmitter. But also tryptophan will form melatonin. And what is the major function of melatonin? Well, a lot of people say, well, it's for circadian rhythm. It is, but its major function is actually antioxidation. It is a mitochondrial protector because it scavenges free radicals, and it upregulates one of the major controllers or antioxidants, which is called superoxide dismutase, and glutathiones. For those of you who have been involved in antioxidation, this is what you need to know. Melatonin is a major antioxidant. And of course, it controls circadian rhythm and sleep. But not just that, it regulates GI, motility, the movement of things through the gut, and GERD, local anti-inflammatory effects, the chelation of transitional metals, neuroprotection. It's involved in anxiety and depression, involved in female and male fertility because it has effect on gonadotropin releasing hormone, and insulin and blood sugar. Of course, as remember, depends on the circadian rhythm. And melatonin, reproductive hormones. Remember, we talked about having all of this in one test. It controls release and timing of female reproductive hormones, when you have the start of menstruation, etc. So if you derange the circadian rhythm, you're going to derange the menstrual cycle. Extremely important. And last but not least, intestinal function, specifically mucosal immune function, secretory IgA, SIG-A. And this is extremely important. Now, what is secretory IgA? Well, SIG-A, we'll call it from this point, is actually the main immunoglobulin in mucus secretions, in tears, in saliva, sweat, in colostrum, and in the GI and the gastrourinary tracts, in respiratory and prostate epithelium. It's everywhere. And it is a major secretory component. That little component that you see here, like this S, double S, is a component produced in the various cells that line things like the intestinal gland, because it keeps IgA from being proteolytically degraded. So there is IgA with this S, this double S, which allows it to survive in the GI environment. It survives in the mucus layer right up against the mucus glands. And it inhibits the inflammatory effects of other immunoglobulins. It wants to damp down the effects of other immunoglobulins. Why? Because when food is coming into the body and bacteria are working on them and so on, you want to keep most of the immune system damped down. You don't want it to just be shooting off at all times. You want the person to be able to eat, to normally have tolerance to that, and so on, and not get involved in major immune effects. But if you do have oral tolerance, you are suppressing the immune response to food antigens, to commensal intestinal bacteria, anything that's coming in through the oral route. In other words, you want the body to only respond with a big response if there is a major issue. So what SIG-A is doing, it's just catching little antigens and so on and saying, everything is okay, rest of the body, I've got this. So it prevents the harmful immune response to actual harmless antigens like foods. It activates specific T cells or cytokines, such as TGF-beta, only when they're needed. So the problem becomes for patients with defective secretory systems. They have circulating immune complexes containing ingested antigens that they develop very high responses to these where there shouldn't be normally. And these are the people who have allergies and various kinds of autoimmunity. So the key functions of SIG-A is immune exclusion, meaning it doesn't want the rest of the immune system to keep shooting off when it shouldn't. It has anti-inflammatory properties, keep the body from being totally in an inflammatory state, and it wants to maintain the homeostasis of commensal bacteria in the gut. It is the first line of defense. It makes sure that the body is able to keep commensals where they should be in the gut and not to be a problem elsewhere in the body. But what happens if you have low SIG levels? Well, if the mucus layer right up against these intestinal cells is dysfunctional, you decrease SIG-A as well as human beta defenses. These are particular proteins that are produced by certain cells in this immune barrier. And if they are not functioning well, you get low SIG-A. If you have a lot of stress, there's adrenal dysfunction, there's mental distress, emotional, physical. That's going to increase cortisol. And what is it going to do? Well, it decreases SIG-A. There we go again. This yin and yang. Chronic infections, Candida, H. pylori, C. difficile, SIBO, all create low SIG-A. Poor dietary choices, low SIG-A. Various types of medications, especially, by the way, antibiotics, which not only screw up the whole microbiome, but they also decrease the mucus layer and create low SIG-A. And chronic food sensitivities, there's a question, which triggers which, but at some point it becomes a real problem. And high SIG-A salivary levels, just to let you know, when you have acute GI infections, acute distress, etc., or viral infections, oral infections, heavy smoking, alcoholism, or certain types of lifestyles will create elevated immune response, high SIG-A salivary levels, and that is not what you want. So you want to normalize SIG-A. You want to decrease stress. You want to create a diet that eliminates most inflammatory foods. And you want to give adrenal support so you can normalize the levels of secretory IgA. And just to finally remember, as I said, in this one report, you're able to see the effect of one particular group of hormones on another. Cortisol has an effect on the stress response. And it's more than just fight or flight, which is what acute levels of cortisol are made for, to get the body to be able to stimulate the muscles to get away from that lion that's trying to eat you. But when you are in chronic stress, mental, inflammatory, like the wrong foods, oxidative, more ROS damage, toxic overloads, or you're overweight, or you're too sedentary, or there's been a bodily injury, there's been a sprain, there's been a fracture, whatever that is, that sets off a cortisol response, and that will affect SIG-A dramatically. It will lower the SIG-A levels. And so finally, chronic stress does what? And what is chronic stress? Overwork, death, divorce, you name it. What is it going to precipitate? Well, it precipitates increased adrenal function, increased cortisol activation. That's the stress hormone. What does it do? Amongst other things, it decreases the gut immune response, that SIG-A response. What happens because of that? There's an increase in pathogens, intestinal permeability, food sensitivities, which then in a circular fashion increases stress hormones. What does that do? That increases toxins. The detox system in the body, especially the liver, is overwhelmed, which brings you to the issue of how do you test for that? We have a test for that. That's another fundamental test of FDN. That's the metabolic profile, including oxidative stress markers. So in this way, I want to thank you for listening to this. We've given you a quick overview of the stress situation, the stress and hormone profile. Now, of course, adding to it the advanced, which is insulin metabolic function. And I think FDN is moving towards that now because it gives you this cornucopia of plenty in one test, the effect of adrenals on salivary functions, the SIG-A, melatonin, its effect and how it's affected, and the metabolic functions, and of course, reproductive hormones, male and female. That's an awful lot of good non-diagnostic biomarkers.
Absolutely. Thank you so much for going over all of that so quickly as well. I know that it kind of pains you to skimp on details. But yeah, we really appreciate your time and kind of the quick flyby overview. I think people watching find it very interesting, and it also helps them decide if, you know, the course is for them or not, if they want to come in and learn more about what we do at FDN. The other panels that Dr. Gonshor was mentioning, we are going to be going over those in the coming weeks, so definitely stay tuned. And thanks so much for being here. Dr. Gonshor, thank you for your time.
It's my pleasure always. All the best.